Hello, my name is Jeremy Humphreys, and I'm presenting gravity and its forces on the world. Let's start off with the question of what is gravity? Why do you land on the ground when you jump instead of floating off into space? Why do things fall down when you throw them or drop them? The answer is gravity, an invisible force that pulls objects towards each other. Earth's gravity is what keeps you on the ground and what makes all things fall. Gravity is a force by which a planet or other body draws objects towards its center. The force of gravity keeps all the planets in orbit around the sun. The next video I'm about to show you is just a short clip on what Men in Physics would explain for you on what is gravity.
We're all familiar with gravity as the reason objects fall, but there's much, much more to gravity than that. Gravity is a long-range attractive force between all objects with mass. It's what keeps us from falling off the Earth, it's what keeps the Earth in orbit around the Sun, and it's what caused the Sun itself to form 4.5 billion years ago. It's amazing to think that every massive object attracts every other in the universe. That means that your dog, the Earth, and a black hole in the Andromeda Galaxy 2.5 million light-years away are all gravitationally attracted to you, and you to them. In the 17th century, Isaac Newton discovered that the strength of the gravitational force decreases by the square of the distance between two objects. So if you're twice as far away, gravity is only 1/4 as strong. He also discovered that the strength of gravity is proportional to the mass of the objects in question. The more massive an object, the stronger the gravitational force. That's why we can all feel the Earth pulling on us, but don't really notice the pull of the moon. It's smaller and farther away. The moon's gravity is strong enough to cause the tides, though. And when I said earlier that gravity is an attraction between objects with mass, I lied. I meant objects with energy. Because in addition to massive objects, gravity also attracts light and other massless but energetic particles, so that a photon of light can be bent slightly passing the sun, or trapped completely by a black hole. Now do you understand the gravity of the situation?
So as he explained in Men in Physics on what has gravity, anything that has mass also has gravity. Objects with more mass have more gravity. Gravity also gets weaker with distance. So the closer an object is, the stronger the attraction is. The further away, the weaker the attraction of gravity. What makes gravity? Earth's gravity comes from all of its mass. All of its mass makes a combined gravitational pull on all the mass in your body. That's what gives you weight. And if you were on a planet with less mass than Earth, you would weigh less than you do here. So on the moon, you would weigh 17 pounds. On Mercury, you would weigh 38 pounds. On Venus, which is very close to Earth, you would weigh 91 pounds. On Mars, you'd weigh 38 pounds. On Jupiter, you would weigh 253 pounds. On Saturn, you would weigh 107 pounds. On Uranus, you would weigh 91 pounds. And on Neptune, you would weigh 114. And you may think, why do you weigh less on Uranus or barely weigh a little more on Saturn and Neptune when they are way more massive than the Earth? It's because the density of mass is spread out over a larger area, so they are not as dense as Earth. That is also the same reason why Mercury, even though smaller than Mars, you would weigh the same. Do you have gravity? You exert the same gravitational force on Earth that it does on you, but because the Earth is much more massive than you your force doesn't really have an effect on our planet. And no matter where you are on the planet, gravity is pulling down on you. What does gravity do? Gravity is what holds you to the planet. It's what keeps the planet in orbit around the sun, and what keeps the moon in orbit around the earth. The gravitational pull of the moon pulls on the sea and causes the tides. Gravity creates stars, planets, asteroids, and black holes by pulling them together into one massive blob. What all does gravity pull on? Gravity not only pulls on mass, but also on light. Albert Einstein discovered this principle. If you shine a flashlight upwards, the light will grow imperceptibly redder as gravity pulls it. You cannot see the change with the human eye, but scientists can measure it with instruments. What has the most gravity? Black holes pack so much mass into a small volume that their gravity is strong enough to keep anything, even light, from escaping. And a black hole is just an area of such immense gravity that nothing can escape it. And that is why it is one of the largest, most powerful forces in the universe. In this video by Kurzgesagt, you'll find out the smallest to the most massive black holes in the universe. We are going to start off with the smallest one, which is a primordial black hole.
Really small. Primordial black holes. The smallest kind of black holes may or may not exist. If they do, they're probably the oldest objects in the universe, older even than atoms. They would have formed just after the Big Bang, when the universe was so dense with violent energy that any tiny pocket that was just slightly more dense than its neighbors could produce a black hole. The smallest primordial black hole that could still be around would be 8 trillion kilograms or so, the mass of a big mountain. And yet they would be no bigger than a proton. A primordial black hole with the mass of Earth would barely be larger than a coin. This makes them very hard to find, so we haven't actually observed any yet. If they exist, they may even be the mysterious dark matter that holds galaxies together.
The next black hole he will talk about, which will move up in size, and as each black hole increases, it has more gravity, which draws more things in and causes a bigger gravitational pull on the things around it.
There. Stellar black holes. To make a black hole, we need to compress enough matter so that it collapses into itself. After that, the more mass we throw at it, the larger it becomes. In today's universe, only the most violent cosmic events can create the necessary conditions, such as the merger of neutron stars or when the core of a very massive star collapses in a supernova. To have a unit to work with here, we'll use the mass of our Sun, about 2 million trillion kilograms. The smallest known black hole has 2.7 times the mass of the Sun, which works out as a sphere around 16 kilometers in diameter, large enough to cover Paris. Another lightweight black hole is the companion to the V723 Mon red giant star. This star is 24 times larger than our Sun, 30 million kilometers in diameter. And yet, it's thrown around by a tiny black hole just 17.2 kilometers wide. This tiny thing bullying the star is so much smaller that we can barely even show them in comparison. One of the largest known stellar black holes is M33X7. It currently spends its time eating a 70 solar mass blue giant bit by bit. As all that stolen matter circles towards the black hole, like water going down a drain, friction heats it up to temperatures high enough to shine 500,000 times brighter than our Sun.
As you can see, black holes are the most massive gravitational forces in our universe. I will skip to the end of the video to show you the size comparison of the largest black hole, which by theory, would have the greatest gravitational pull of anything in the universe. The largest black hole, or the largest gravitational force in the universe, is Ton 618. He will explain more about it in this short clip.
Shining with the brightness of 100 trillion stars, visible from 18 billion light years away. It has an incredible 66 billion solar masses, a black hole so large that it would take light a week to reach the singularity after crossing the event horizon. About 11 solar systems could sit inside of it, side by side. It may very well be the largest single body in the universe, but in reality, it's probably even larger. Since Ton 618 is so far away, we only see what it looked like 10 billion years ago. In any case, black holes are scary and mysterious and gigantic. They'll be here after everything else dies and growing larger and larger. Okay, now let's do the trip again.
Now he is going to do from the smallest black hole to the largest in a quick clip.
Smallest possible black hole all the way up to the largest.
So you have primordial black holes, which are the size of an atom, and it goes all the way up to Ton 618, which is the size of 11 solar systems across. There's the largest star. So as you can see by this short clip, the Ton 618 is a massive, massive black hole. The largest body in the universe. So now that you know what has the most gravity, could we live without gravity? And the short answer is no. Gravity is very important to us. We cannot live on Earth without it. The sun's gravity is what keeps the Earth in orbit around it instead of veering off into space as a rogue planet. And it keeps us at a comfortable distance in the Goldilocks zone, so we are warm but not too hot and not too cold. And it holds down the atmosphere, which allows us to breathe. Now, could you live under more gravity? In this article from the University of Zagreb in Croatia, Nikola Polak and his colleagues calculated that the strength of a human bone can withstand forces of more than 90 times Earth's gravity. But having your bones that strong would do nothing without you moving around, which can cause up to 10 times of force on your bones than you are just standing still. But being able to withstand 10 times Earth's gravity is nothing if you don't have the muscles to do it. So Polak calculated that at 5 times Earth's gravity, not even an elite athlete would be able to move from the seated position. For a 110-pound human has the equivalent of squatting around 320 pounds. For maximum gravity at which we could take a step, they turned to a team from the Icelandic strongman who once walked 5 steps with a 1,430-pound log on his back, smashing a 1,000-year record. Polak says that Bjornsson's feat is a good competitor because the load on your legs and core muscles is equal to the strength of the gravitational field would put on you. However, he is not just an average person, as you can see in the picture to the right. He is 6'9" and weighs over 400 pounds. And they estimated that he would be able to walk on a planet around 4.6 times of our gravity. And so in their short conclusion of their paragraph, they figured they could live on a planet between 3 and 4 times Earth's gravity at the max. But even then, you would need training. So, is gravity the same everywhere on Earth then? No. Gravity isn't the same everywhere on Earth. Gravity is slightly stronger on places with more mass than on places with less mass. NASA uses 2 spacecrafts to measure the variations in Earth's gravity. The spacecrafts are part of the Gravity Recovery and Climate Experiment, also known as GRACE. GRACE detects tiny changes in Earth's gravity over time. These changes have revealed important details about our planet. For example, the GRACE monitors sense changes in sea level and can detect changes in Earth's crust brought on by earthquakes. If you can see in this picture right here, the spots with blue have less gravity, while the spots with red have more gravity. And if you notice, the spots with red are primarily where mountain ranges are. And this is my reference page. I use the nasa.gov website, the Discovery magazines, and a Google Scholar on gravity and what it is. I also use my 2 information science YouTube videos that I showed you throughout the clip. And that was my presentation on gravity. Thank you.